This honors geometry lesson is on 6.1 geometric mean. The objectives are to determine the geometric mean between two numbers and to state and apply the relationships that exist when the altitude is drawn to the hypotenuse of a right triangle. Suppose r, s, and t are positive numbers with the proportion r over s equals s over t. Then s is called the geometric mean between r and t. In example 1, we are going to find the geometric mean between the given numbers. So remember, from the proportion, r and t are going to be represented by 3 and 7. So we are trying to find s in this proportion, which is the geometric mean. So when we set up our proportion, we're going to take 3 over s and set that equal to s over 7. So if we use our properties for solving proportions, we're going to cross multiply. So s times s is s squared, and 3 times 7 is 21. So we know to get s by itself, we are going to take the square root of both sides. So in this case, the geometric mean between 3 and 7 is root 21. For the second example, we're going to let 6 and 15 represent r and t, and again, we're going to find s, which is the geometric mean. So if we take 6 over s, set that equal to s over 15, if we cross multiply, we have s squared equals 90. And when we take the square of both sides, we're going to get s equals root 90. Remember from previous lessons, we want to make sure we're completely simplified. Since 90 contains the perfect square 9, we're going to go one step further and simplify into root 9 times root 10. So when we simplify, we're going to get the geometric mean between 6 and 15 is 3 root 10. For example 2, we are given that 8 is the geometric mean between 96, and we're going to find that last number. So if you go back up to the proportion, 8 is going to represent the value for s, and 96 is going to represent the value for one of the two numbers. So in this case, we're going to let 96 represent r. So based on this information, we know if we set up our proportion, our geometric mean is 8. So we're going to substitute that in for s. We're going to say that 96 is going to represent r. So in this case, we're finding the value of t. So using the properties of proportions, if we cross multiply, we're going to get 96t is equal to 64. And then if we solve our equation and divide by 96, we're going to see that t actually equals 64 over 96. So if we simplify 64 over 96, we're going to actually see that t is equal to 2/3. So in this case, 8 is the geometric mean between 96 and 2/3. It is okay to get fractions and to get radicals as either the geometric mean or the numbers that represent r and t. Remember from the previous chapter that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So let's take a look at triangle ABC, which is the large triangle, and go ahead and mark the angles. So we know angle C is 90 degrees. We're going to give angle A 1 tick mark and angle B 2 tick marks. Let's take a look at how ACD, which is the small triangle, is going to be similar to triangle ABC. So if you look at triangle ACD, or ADC, which is a small triangle, we can see that angle A is shared by both the small triangle and the large triangle, and that both of them have a right angle. So in this case, we know that these two triangles are similar based on angle. So now I know that in the small triangle ACD, that angle is going to be congruent to angle B in the large triangle. For the medium triangle, which is triangle BCD, we're going to go ahead and prove that similar to the large triangle ABC. So again, we can see that both the medium triangle and the large triangle share angle B, and that they both have a 90-degree angle. Therefore, by angle, the medium triangle and the large triangle are similar. So we now know that this angle here is going to be congruent to angle A. So now we can see that all three triangles share the same congruent angles, therefore all three triangles are similar to each other. So when we divide the altitude of the hypotenuse into two segments, we're going to go ahead and remark our diagram. And we're going to write our similarity statement so we can use those for the corollaries that are coming up. So based on our markings, we know that triangle ABC, which is a large triangle, is similar to triangle ACD, which is a small triangle, which is going to be similar to the triangle CBD, which is the medium triangle. So we're going to use the following similarity statement throughout the lesson today, so make sure you write that on your paper. Corollary 1 states, when the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. So the segments of the hypotenuse are going to be represented by x and y, and the altitude is going to be represented by h. So based on this corollary, we have the following proportion. X over h is going to equal h over y. So if you look at your markings, we know that AD in the small triangle is similar to, AD in the small triangle is similar to H in the medium triangle, and we also know that H in the small triangle is similar to Y in the large triangle. So if you think about the following proportion, X over H represents the short side of the small triangle over its long side, and the second ratio, H over Y, represents the short side of the medium triangle over the long side of the medium triangle. So therefore, H, which is the altitude, becomes the geometric mean between those two segments. Let's use the following corollary to solve example 3. We're going to find the values of A, B, and H. So we're going to go ahead and just remark again. So we call this 1 tick mark, 2 tick marks. This one had the 2 tick marks here, and then this has the 1 tick mark, just so we can mark our similarity. The first thing we're going to want to do is find H. So we know that H is going to be the geometric mean between AD and BD. So if we set up our proportion, we know that H, the geometric mean, is going to be the geometric mean between 6 and 9. So if we solve our proportion and cross multiply, H squared is going to equal 54. And when you square both sides, H is going to equal root 54. And if you simplify root 54, we have, so we have 9 times 6. Okay, so the square root of 9 times 6, you want to write this out. Square root of 9 times root 6. Square root of 9 is 3. So the height, or the geometric mean, is 3 root 6. So for the second example, let's go ahead and find B. So we're going to find B here. So B has a couple different relationships. So B is the hypotenuse of the small triangle, or it can be considered the short leg of the largest triangle, so the overall triangle. So we can set up the following proportion based on that. So for the second one, we can say 6 over B is equal to B over 15. Okay, so 6 over B represents the short side of the small triangle over its hypotenuse, and B over 15 represents the largest triangle, so its short side, over the entire hypotenuse of AB, which is 15. So now if we cross multiply, we're going to be left with B squared is equal to 90. And if you square both sides, B is going to be equal to root 90. And again, we want to make sure we simplify. So 90 contains the perfect square of 9. So this breaks up into root 9 times root 10. So if we simplify that, we know that the value of B is going to be equal to 3 root 10. For the last example, we're going to go ahead and find A. It's going to be our third step. And we can use the following proportion for A. We can say 9 over A. I'm going to try not to make my 9s look like my A's. is going to be equal to A over 15. If you look at all three examples, so in example 1, we cross multiplied the two h's to get h squared. In example 2, we cross multiplied the b to get b squared. And in the last example, we're going to multiply a to get a squared. So each time we're actually using the whole property of the geometric mean to find the missing segments. So for this one, if we cross multiply, we're going to get a squared is equal to 135. And if we square both sides, a is going to equal root 135. So if we go through our list of perfect squares, we know that 9 times 15 equals 135. So root 9 times root 15. And if we simplify, we know that a is going to be equal to 3 root 15. In example 4, we are given the altitudes of the hypotenuse of a right triangle, divided the hypotenuse into two segments of 20 centimeters and 25 centimeters in length. What is the length of the altitude? So if we quickly sketch a right triangle and we drop the altitude, we know that one segment is going to be represented by 20 centimeters, and that the second segment is going to be represented by 25 centimeters. And they would like us to find the altitude, which is the height. Now we also know that that's going to represent the geometric mean between the one segment that's 20 centimeters and the second segment that's 25 centimeters. So we can go ahead and set up our proportion using geometric means. 20 over h is equal to h over 25. So when we cross multiply, we know that h squared is going to equal 500. And when we square root both sides, we're going to get h is equal to root 500. And within 500, it contains the perfect square of 100. So this would be equivalent to saying root 100 times root 5. And the square root of 100 is 10. So the height for this triangle is going to equal 10 root 5. The second corollary states when the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. Using the same diagram, we can go ahead and remark our diagram. So if we look here, based on the corollary 2, we can say that x over b equals b over z. So what that relates to is x is the short side of the little triangle over b, which is the hypotenuse of the little triangle, and that's going to equal b, which is the short leg of the entire triangle, over its hypotenuse, which is z. So if you think about it, x over b represents short side of the small triangle over the hypotenuse of the small triangle, and that's going to equal the short side of the overall large triangle over its hypotenuse, which is z. We can also do that to the medium triangle to the large triangle as well. So for the second proportion, we can say y over a is equal to a over z. So again, y in this case is the long leg of the medium triangle over its hypotenuse, and that's going to equal the long leg a of the big triangle over its hypotenuse. So for the first example, you want to do some notations. X over b represents the short leg of the small triangle over b, which is the hypotenuse of the small triangle. And that's always going to be equal to the short leg of the large triangle over the hypotenuse of the large triangle. And that's always going to represent the relationship between the smallest triangle to the largest triangle. The second proportion is going to relate the medium triangle to the large triangle. So in this case, y over a, so y represents the long leg of the medium triangle over a, which is the hypotenuse of the medium triangle. And that's going to equal the long leg of the large triangle over the hypotenuse of the large triangle. So that might be a little bit easier for you guys to memorize. So based on corollary 2, let's look at example 5. We're going to find the values of a, h, x, and y. So let's always start with our geometric mean, which is h. So we know that if we take x over 8, so x over 8, x over 8 is going to equal 8 over 16. Okay. So x over 8 represents the short leg of the small triangle over its hypotenuse, and 8 over 16 represents the short leg of the large triangle over 16, which is its hypotenuse. So if we cross multiply, we're going to get 16x equals 64. And when you divide 64 by 16, we're going to get x equals 4. So if we recap, remember that from the previous triangle, the proportion was x over 8 represents short side of the small triangle over its hypotenuse, and 8 over 16 represents the short side of the large triangle over its hypotenuse. So if x is 4, we can easily find y. So 16 minus 4 tells us that y is equal to 12. So now that we know x and y, we can now use h as the geometric mean. So for the second step, we're going to go back to the theorem and the definition of geometric mean, and we can take 4 over h, set that equal to h over 12. So when we cross multiply, the h squared is equal to 48. And when you square both sides, h is going to equal root 48. Always look for those perfect squares. So in 48, the perfect square of 16 is there. So 16 times 3. So the height, altitude, or geometric mean of this triangle is going to be equal to 4 root 3. The last thing we want to do is go ahead and find a. So for our third proportion, we can go ahead and say 4. Oh, sorry about that. Written the wrong one down. Give me one sec. So to find a, we can actually use the second corollary. So for this one, we are going to take 12 over a and set that equal to a over 16. So if you go back to the previous slide, this represents the long side of the medium triangle over the hypotenuse of the medium triangle, which is going to be equal to the long side of the large triangle over the hypotenuse of the large triangle. So if we cross multiply, we're going to have a squared is equal to 192. And when we take the square of both sides, we get a equals root 192. This one's a little tricky to simplify, but there actually is a perfect square in 192, and that's 64. So root 64 times root 3 gives me an a value of 8 root 3. So we know that the value of a is equal to 8 root 3. So this is the end of our lesson. I know this lesson was a little tricky with all the proportions. If all else fails, go back to what you learned in Chapter 5, draw your congruencies, split up the triangles, and just set up your proportions using what you know from previous knowledge. If you are having trouble understanding the Corollary 1 and Corollary 2, that's okay because you can go back to what you learned in Chapter 5. So if you have questions, go ahead and write them down and come in and see me in class tomorrow.